Okay, we did solving trig equations in grade 11. So I'm going to do this example. It was exactly from your grade 11 course. Okay, so step 1. So on this pink paper I have for you, the step 1 is your algebra. So here's what we learned in grade 11. If you have one variable, you isolate it. Does that make sense? One variable, get it alone. If you have two variables, so for instance here has a sine squared theta and a sine theta, those are different. Just like how x squared is different than x. Okay? Because square footage and linear footage are different. They can't be put together. So if you ever have two variables, boom, equals 0 no matter what. You have to start with that. And then we had all these things from grade 11 that we mastered, and I'm not going to go over because we're supposed to have them mastered coming in. We can factor using GCF, simple trinomials, complex trinomials, difference of squares, and if nothing worked, we always had a formula as well. Then we went into trig mode. So this is what the goal of the algebra was. Trig equation. So it equals a trig value. So we remember seeing that. Then flipping. So step 2 is the angle part of it. So once I have an equation equal to a trig value, I ask myself, where could it be? And I use Astica. So step 1, Astica, figure out your quadrants. Here's some tricks for you. Are you right there? Sine is y, right? Remember, sine is the y letter. So where does it split? Up and down, because y is up and down. Cosine is connected to your x, so how does it split? Left and right. And tan is the diagonal split. Okay, step 2, we did a reference angle by inversing. And then step 3 is we figured out where we actually were. Okay, does that all look familiar from grade 11? So those are your big steps. Okay, so here we go. Step 1, what kind of algebra should I use? Should I isolate or should I make it equal 0? Isolate. There's only one variable, so let's subtract 7. Okay, so remember this part is you finding just a trig value. There's trig values and then there's angles. Those are different things. Okay, so now we go into the where. Where am I? So you have to process your Astica. And where is cos negative? Where would cos be negative? Did you pick the left-hand side? That make sense? Okay, so now I want to figure out what the reference angle is. That's my next step. So how do you get angles? You do a inverse. Okay, so here's a trick. When you do the inversing, you never put the negative in. Okay, just like Pythagorean theorem, we didn't put the negative in. We analyzed negative positives after because of the location. Same thing here. Don't put negatives in to the math, you put the negatives into the locations, and that's what we've already done. Okay, so go to your calculator. Now, we're going to learn more about this, but I want to answer this angle in a degree answer. I need to get myself a degree answer. So I'm going to make sure my calculator says degrees. Cos inverse bracket 3/5. Okay, so 53.5 130 is the reference amount. So what is a reference again? How much you're off of the x-axis. Okay, so now what is this angle at? How do I get that? So what is this line right here? 180, and you're less than 180. Don't forget, in this course you have to accurately round to 3 decimal places or you're getting deductions. And then what would we say about the other one? Would you agree that it's that much bigger than 180? Does that make sense visually? Okay, does that kind of ring a bell? That's an exact grade 11 question. Okay, so let's try the next one here. Okay, so I already can see sine squareds and sines. I see 2 variables. Equals 0, that's where I want to be at. So that's good. So now we're going to go into this spot. So 2 variables equals 0. So can I factor it? Can you look through your factoring? Do you see what style it would be? It's actually a complex trinomial. Why? Because it starts with a something squared part, right? Okay, so I need you to give me 2 brackets. What in the front multiplies to 3 sine squared theta? You don't have many options. 3 sine theta and just a sine theta, right? Everyone remembers what I'm doing? I'm breaking down the FOIL. Do you understand the last times the last has to make that? So what do you do to make 1? What times what? 1 times 1. Okay. Now the outsides put together with the insides have to end up making me negative 2 sine. So where am I going to put a plus and where am I going to put a minus? Looks like I'm going to need to have a minus 3 sine and a plus. Do you see all your FOIL? And you can quickly FOIL that out just to make sure we did it right. First times first, yep. Outsides and the insides, yep. Last times last, yep. Okay, now I'm going to solve for the trig value. This is a fraction answer. Does anybody remember how to do that? Maybe we'll start with the easy one over here. What would sine theta have to be in this bracket? Positive 1, right? Because then 1 subtract 1 makes the 0. And this one, opposite divide. Opposite divide. Okay, we're going to do this one first. You know why? I'm not going to touch my calculator. I can solve this somehow not using my calculator. If I didn't use my calculator, what do you think I have to use? My unit circle. Okay, so why did I decide to do that? Because I recognized 1 on the unit circle. So what is sine again? What are we always doing to sine? Y. So where would you ever see this y value of 1? You would see it up there, right? Okay, so this is it. That's the only time I ever see a height of 1. So this is now going to be different. Because this is telling me I have to give my angle in radian language. So if you answered me 90 degrees, you're wrong. What should I answer instead of 90? Radians, pi over 2. Okay, so this one, 1/3, I don't see that from a unit circle. So I'm going to be in my calculator. So let's start with where. Where is this angle going to be as an answer? So I'm thinking, where would sine be negative? Did you pick the down? The lowers? Now I need you to do this. You're going to sine inverse just 1/3, no negatives again. We put the negatives into the spot. But here's something new. I need you all to do this. Do you see how the top says degrees? This time I don't want to be in degrees. I want to be answering in radians. So I'm going to change mine. Mine's this mode button. And you can see how now it'll say rad at the top. Wave at me if you can't find that button that changes your calculator at the top. Shift mode for second mode. Anybody not find their button? Radian? Oh, same. So you go shift mode. Shift mode. Yeah. Say R at the top. You know that you can't use that one on the exam. So you probably want to get used to another calculator. Do you want to start borrowing one for the year? Okay. Yeah, because that one has graphing on it, so you can't use it. Okay, so we'll use this for the year. Okay, good? Everyone's got a number? Radians, remember radians are really small, right? Because there's only 6.28 in a whole circle. So that makes sense, 0.3398. Okay, so that's telling me the space between there. That's just a reference, the space right there. So how do I get this answer? So this line is, we're not going to say 180. What are we going to say instead of 180? Pi plus. because I'm bigger than pi, right? I'm bigger than the 180. So plus pi is 3 point. And what are we here? How would I get to this position? What am I connected to? 2 pi. I'm smaller than 2 pi. And accurately to 3 decimal places. So for me, I kept that rolling in my calculator, and I kept just trying to get it back on my calculator, 2 pi minus answer. So that I never physically typed in this. I was always trying to do pi minus plus answer, 2 pi minus answer, and getting that answer back in there. If you can play around with how to do that in your calculator. Okay, so this one, we're ready? So I would see what kind of algebraic strategy, which one of the paths are we on? 2 variables, we got the 0, so then I'm checking the factorings. Complex again, right? So 2 brackets, let's see if we can make this work. First times first has to make this. So there's only one way to make that. What times what? 5 cosecant and 1 cosecant. Last times last has to make the last in that. 1 times 1. Because there's a subtract there at the end, I already know 1's plus 1's minus. I need you to get me a minus 4 out of the outside insides working together. How do you make a minus 4 out of that? Does your FOIL work out? You can always check, right? Okay, I need a trig value. So this one's a fraction. Okay, so our calculator does not have these features. We don't have, if you look, you don't have a cosecant button, you don't have a cotangent button or a secant button. So what can we do? What do we know about cosecant? We've got all of our stuff up on the board there. What about cosecant? It's a flip of sine, right? It's the sign flipped around. So I'm going to do that. I'm going to change this to a sine, and I'm going to make a flip. So 1 over 5 becomes 5 over 1. And I'm going to flip. What happens to the number 1 when you flip 1 over 1? Nothing, right? 1 over 1 becomes 1 over 1. Guess what? We just did this one, didn't we? We recognized it from our unit circle. Where is sine 1? Where is y 1 on that unit circle? I'm going to answer pi over 2. How did I know to answer in a radian language? It told me right there. told me to give the angle answer somewhere between 0 and pi. Okay, this is not going to work. So you have to make a statement called no solution. And then here's a couple things. So let's say you didn't know this and you typed it in your calculator and tried to inverse 5, error. Okay, here's something to know. On a unit circle, sine is the y values. If your y value is anything outside of 1 or -1, it will never work. Same with your cosine values, because cosine is x. The trig values for cos are never going to go outside of 1 and -1. So that's something to know. When you get to that point, there's no solution. Okay, only for cos. And sine. Okay, x's and y's, unit circle. X and y never go past the -1 to 1. Okay, I need you to write no solution. If you don't write anything, you get a deduction. So you have to physically write, there's no solution for this. Okay, last one. Let's see if we can do one more and let you work. Okay, we need to start with just algebra before we tackle the trig stuff. So algebraically, what should I do? What did you say? Equals 0. Two variables, gotta have the 0 or else you can't go anywhere. Now I gotta say, what do I recognize? Do I have any of those factorings that I know about? Simple trinomial, because it's got the trinomial and it's just the one squared part. So secant theta, secant theta. And then I need to multiply to 15. And then I got to remember that my combo needs to make a 2. So can you think of something that multiplies to 15? And then you can make a 2 out of it. 3 and 5. There's going to be a plus and a minus because there's minus 15. So I need to get that to be a minus 2. So now your trig values are -3 and +5, because that's the number that would make a 0 out of the brackets, right? That's what that is. Okay, now we ran into the same problem as last time. We don't have a secant button. So what should we do with secant? Switch it to cos. So now we're going to write the cos theta, and then we're going to make the flip. So 1/3. And then we're going to do the same thing over here. Just glance. Do we see anything with the unit circle? No. Sometimes I might see a half or a 1 or a √2/2. Then I'm just looking on the unit circle. Don't see anything unit circle. So I activate Astica. This one's negative. So where will this angle be? On the left. This angle answer will be on the writes okay, so now I'm going to grab my calculator and I'm going to be doing this cos inverse to get the reference. And this time it says for all angles. So this is a little bit different. You might see all angles, or you might see angle can be any real answer. You're going to answer in radians. So I need you to be in the radian mode when you're doing this. Okay, reference is good. We're all matching. I'm going to do pi minus that much. Would that make sense to you? And now what? It says for all answers. So if I could just do these answers endlessly, how do you write that? Do you remember? If you could say this rotation or the next rotation, or it could go around again, or it could go around again. Plus, how do you write a circle rotation? 2 pi k, where k is the element of the integers. So you can rotate any integer amount of a circle. So all that includes answers forever and ever and ever. You rotate around and around and around. Okay, so this same thing here, this one would be pi plus How are your numbers coming out? Good? Okay. Should I let you try this one on your own? You're going to start with the cos inverse, and then you're going to get the reference, and you're going to get me some finals. And I want endless answers, so you're going to write plus 2 pi k, kei at the end of them.